Hello everyone. Today we are going to learn about polynomials, a very basic understanding of polynomials, the types, probably a bit of understanding the terminologies, how do we recognize if it is a polynomial or not, just the basics, okay? Let's just stick to the basics. Let's get started with the very first expression, 2x. Now 2x is a polynomial with one term and it is called as a monomial. Let's take another expression 2x plus 4. This has two different terms. I'm going to give it a name called as a binomial. So a polynomial with two terms is binomial. So what do you think a polynomial with three terms will be called as? Yeah, that would be a trinomial. Okay. So what about a polynomial with four different terms? It will be called as a polynomial. Okay. Now, all of these are polynomials. It's just that based on the number of terms, the first three have a specific name given to it, right? Any expression with more than three terms will be called as a polynomial. So when I have five terms, six, or maybe seven terms, eight terms, I'm going to call it as a polynomial instead of giving a particular name to it, right? Like we're just generalizing it. Now, all this comes under one hut or one roof, that is algebraic expressions. Okay, so all this, a polynomial is a type of algebraic expression. So what is algebraic expression basically? It's whatever you see on the screen. It's basically your numbers, your alphabets, your operators, they're coming together or combining to form a mathematical phrase or a mathematical sentence. All right, it's basically combining to form something. Right, that is your algebraic expression, hence we call these types of it. Okay, with this, let's dive a bit deeper and understand if 2 is a polynomial or not, right? So 2 looks just a number, it's just a number, it's just a constant. So how do we tell it is a polynomial? We can express 2 as 2 times x to the power of 0. Okay, now let's understand what the concept of x to the power of 0 is. When I write anything raised to the power of 0, it becomes 1. So when I say 2 raised to the power of 0, 1. When I say y raised to the power of 0, 1. When I say a random number, I don't know, 3, 7 raised to the power of 0, 1. Okay, anything raised to the power of 0 becomes 1. With that understanding, I can write my constant in terms of an expression. So when I write it in terms of an expression, yes, it becomes a polynomial. All right. Anything that I'm able to express with respect to a polynomial, in the sense an expression, where I have a constant, a variable, coming together or combining to form an algebraic, a mathematical phrase, that we call it as a polynomial, right? So now, understanding this, 2 times x to the power of 0 can be written as 1. So 2 times 1 is, I'm getting back my constant. So hence I'm able to express it. I'm just doing a bit of manipulation here and there, right? So that I can express it as a expression, okay? Now, similarly, what about 0? Do you think 0 is a polynomial or not? Just get rid of that. Okay. Yes, 0 will become a polynomial. The same reasons, right? I can express my 0 as 0 times x to the power of 0. Hence, that is a polynomial. Okay. So far, so good. Let's get into understand the expressions, terminologies. Okay. Now, I'll write down an expression 2x squared plus 3x plus 5. All right. Now, this expression has different terms, right? Every term has a name given to it. Now, for example, this term, we have 5. 5 is a constant. It's a number and it's called as a constant. The reason it's called as a constant is because it doesn't really have anything next to it. When I say anything, I meant to say a variable. Okay, doesn't have a variable or so next to it, hence it's just there all alone. We call it as a constant. Now, this and this, these alphabets are called as the variables. Now, what are variables? They are values that can change. They vary. Okay. So anything next to the variable, any number which is next to the variable, it has a special name given to it. It's called as the coefficient. Okay. Now a coefficient of x square is 2. Okay. Let's take another example. Say I have 2x cube. What is the coefficient of x cube? It will become 3. Okay. Considering another example, 2x cube plus 5x square plus x. I want to know the coefficient for x. Okay, it's going to be 1. The reason, when I just write the variable as it is very obvious that it means that it is multiplied with 1. Okay, anything multiplied with 1 becomes the number or the value itself, right? So when I say 5 times 1, it is 5. So when I say a times 1, it is a. Similarly, x times 1 will become x. And so it's not really important to write down the 1, hence we skip it or we just ignore writing it, okay? But that doesn't mean it doesn't really have a coefficient. When I ask what is the coefficient of x, the answer will be 1, okay? So that's just basic understanding of your terminologies. Now coming to the power. When I have nothing written over here, see, x to the power of there's nothing. That means that there is 1 there, right? We just don't mention it because it is obvious, right? So there are two powers over here, 2 and 1, and the highest amongst or the greatest among the two powers is obviously 2. So our 2 becomes the degree of polynomial. Okay, so when I ask degree of a certain polynomial, the highest power that is present in that polynomial will become your answer. Let's take an example mm, of 3x to the power of 50 plus 5x to the power of 49 plus x plus 4. What will be the degree of polynomial here? The highest power over here is 50, so hence 50 will become the degree of polynomial. All right, it's as simple as that. Now, the powers present in the polynomial should always be a whole number. This is very important because this point will help you recognize if the expression is a polynomial or not. Okay, so here the expression is a polynomial because all of my powers are whole numbers. Okay, let me give an example where it contradicts that statement. So 3x square plus 4 root x. Now this is not a polynomial. The reason is I can write down this expression in terms of power as, so I'm converting or I'm manipulating my root x to become a power, and in terms of power it is expressed as 1 by 2, or anything raised to the power of half is basically we're talking about the square root. All right, so it's like square root of let's say 2 can be written as 2 to the power of 1 by 2. Square root of 120 can be written as 120 to the power of 1 by 2. Okay, so it's just that. So here I have half, and half is not a whole number, hence this expression won't be a polynomial. Similarly, let's take another example where I have 3x plus 4 by x. Okay, 3x squared plus 4 by x. Now this can be written as 3x squared plus 4x raised to the power of negative 1. Now, why did I write negative 1 there? That's another concept or understanding of math. When I have anything in reciprocal, or when I have anything as a fraction, or in p by q form, or in the denominator, to be very much clear, I can, and I want the denominator to come to the numerator, I want to send it up. So when I do that, the power of the variable or the constant in the denominator becomes negative when it comes to the numerator. So here, when I have nothing, it's obviously 1. So when it goes to the numerator, it's going to become negative 1. Similarly, if I have 1 by uh, 2x to the power of, I don't know, 5, I have to send that to the numerator. It's going to be 2x to the power of negative 5. Okay. So that's how I got this. Now, negative 1 is not a whole number, hence this expression is not a polynomial. All right, that's how you identify if it is a polynomial or not. Let's move on to understanding the types. Okay, now we saw what the powers are doing, and based on the powers, we have different types. Now, let's say I have 3x plus 1. This has 1 as the degree of polynomial, or the highest power of that polynomial is 1. So this becomes a linear polynomial. Okay. Now let's say I have another example of 3x squared plus 2x plus 1. So if you see here, the highest degree of polynomial, or the highest power amongst all of the powers, is 2. So this becomes quadratic polynomial. Okay. Now, what if I have a 3 as my highest degree of power? 3 is the highest degree of power. It gets a special name again called as a cubic. So based on the power, everyone has a different special name given. Let's say I have 3x plus 4x squared. Now this is a polynomial which is using only one variable or only one alphabet. So this becomes a polynomial in one variable. Okay. And if I have 3x plus 4y plus, this becomes a polynomial in two variables. Okay. So because I have x and y, these two are different alphabets, they are not the same, hence it becomes polynomial in two variables. Let's say I have 3x plus square plus 4x plus 7z plus 6y. This is a polynomial in how many variables? We have 1, 2, 3 different variables. So polynomial in 3 variables. Okay. So this is polynomial types based on the number of number of variables. All right. Now let's say you want to give it a name to your polynomial. Okay. So I have 2x squared plus 4x plus y. 4x plus 6. So I'm going to call it as p of x. All right. So it's just that I am giving this entire polynomial particular name, or I'm kind of defining it, okay? Or I'm denoting this polynomial with a particular name. So if I have maybe not x as my variable, I have y, 4y plus 7 or something. This will become p of y, okay? So the variable over here is what's going to change. Now, it's not important that we have to use p. We can use any other number, alphabet. I can say it as f of x or f of y. Okay. So everything depends based on what variable you've used in the polynomial and what you're going to write it inside the brackets. Okay. So basically, since polynomial p, we normally just write it as p of x and just determine it that way. Okay, but it can be different in different textbooks. Just follow what is taught to you. All right, so that is it with this lesson. To have a quick recap, we understood what is polynomial, the different types of it, um, the constants, the coefficients, the basic terminologies. Then we understood how it is denoted. We understood the degree of polynomials. We understood that it has to be a whole number. We understood what is the types based on degrees, that is linear, cubic, and quadratic. Then we understood with respect to number of variables. Yeah. So that will be it for today's video. I really hope that you understood. If you have any questions, you can comment down and I'll try my best to answer them. And thank you so much for watching.